Hello everyone. So in this video, we are going to talk about insurance and how continuous random variable are related. So basically, we are going to talk about insurance related random variable. So let X denote the actual loss amount random variable. Then Y denote the payment random variable. So these are two random variables we are mainly interested. So X is loss amount and Y is payment. So usually when a loss occurs, the payment is not going to be more than X. So random variable Y is usually less than or equal to X, the value Y. Before we continue, we need to talk about truncation and censoring. An observation is truncated from below, left truncated at D if observation below D are not recorded, but above D are recorded. So in this case, so you have the random variable and the left side below the loss below D is not recorded. For example, if D is deductible, any loss below deductible may be not reported to the insurance company. So when that happens, it's called left truncated. An observation is truncated from above if it is at U, if at or above U are not recorded, but below U are recorded. So you can have I here, and any observation occurring here is not recorded. Anything below U is recorded. Usually you will see left truncated, that's a popular one to see in insurance field. And then the next one is an observation is left censored from below at D. If observation below D are recorded as D. So anything happen below D is recorded as D. So let's say you have a loss less than D, then it's recorded as D. So that's called the left censoring. And the other one is right censoring, which says anything above that value is recorded as U. So if you have a loss above U, then it's recorded as U. So this is like cap, maximum. So usually what you see in insurance is left truncated and right censoring. So these are the two scenarios you will see. This is come from deductible, and then this is come from cap, basically maximum loss covered under insurance policy. So let's say you are the insurance policy is maximum covered is 100,000, and then the loss actually 300,000. Then still the insurance company pay on the 100,000. If there's a deductible, they have to use the deductible too. But if there's no deductible, then the maximum payment will be up 100,000, not 300,000. So this is the actual loss. This is the cap, the maximum loss payment. So you will see a right censoring and left truncated in many insurance applications. So here you can see that two random variables we want to define. One is called the per payment, which is in next slide, and the other one is per loss. Per loss random variable, sometimes called as left censored and shifted variable. And per loss random variable, another name left censored and shifted. So so it's left censored because values below D are not ignored, but we set equal to 0. Okay, so left censored. So you can see anything below D, we set at 0. So this is left censored. And then shifted. So that's why you have the left censored and shifted. So and so this one is called as the Perles random variable. The reason it's called the Perles random variable, it take on the value 0 whenever loss produces no payment. So you have like So you have loss in the payment. The loss produced payment if it is above a deductible amount. D is deductible amount. So the loss, what it does, it still show that there is a loss, but it does not show exact value. It's set as zero. So if we graph this, it would be look like this. So this is T. So until D, the, the loss random variable is zero. And then after D, it's become x minus D. So this side is x, this is YL. And now with this one, you can really see the expected value of YL. And we can integrate from 0 to infinity. YL, FYL, dx, but YL equal x minus t. So you need to adjust the limit because after d, because 0 to d is 0. Because you can see it's 0. So it's really from d to infinity. Then the value is actually x minus t because you have to use the deductible. Then f of x, the random variable density function, and so here you can see the other random variable we want to discuss, per payment random variable. So now this random variable is does not define um, if loss is really less than d. So x is loss. But if loss is less than d, then it's not defined. So really, if you graph this, you will see that it's look like this. So there's no line between 0 and d. This side is YL, YP payment, and this side is x. So x minus p. So you can see that the per payment random variable is actually a loss random variable, but given it's positive. So positive start at D. So basically YP is basically YL given that YL is positive. So we can calculate the expected value of YP. So you can see the formula. This is expected value of YL, but you have condition. So you have to calculate the probability YL is positive. So this would be 0 to infinity YL, and then the density function, and divide the probability YL is positive, which is 1 minus YL become positive when x is more than D. So that's why so this is basically probability fx. I mean, the random variable x is more than D, which is 1 minus D. So this one is called the mean excess loss function. This function, mean excess loss function. So now we can try to connect these three random variables. You can see that um, if I have x as original loss amount with PDF of fx and CDF fx, then I can connect this. So YL is defined as YL random variable. This is basically x minus p plus. So basically that means YL plus D equal x. So y equal x minus D. That means y plus D equal to be x. So that's what you will see in here. Or you can use this one to get that function. So let's write the this function. This is probability YL less than or equal to y, but YL is basically x minus D. So that's basically x is less than or equal to y plus D, which is fx y plus D. So that's what this one. So then you have the other formulas too, how to get the density function, and then how to get the CDF function. Both are included. So far we talk about deductible. What happens if there is a policy limit or cap? If policy limit is, let's say, U, then if there's no deductible, then we use Y, which is maximum. This is basically max XU. That's what this one means. That's the X if X is less than or equal U, and U if it is more than U, because remember it's censored now. Censored from above. Again, we can calculate the value of Y, which is going to be 0 to U, X fx dx. From U to infinity, you still have U time fx x dx. You can take U and then you can get U to infinity fx dx is going to be probability, and where x is more than U. So that's why this part is so as it is. So, so basically, I'm breaking from 0 to infinity integral equals 0 to U plus U to infinity. Then simplify this integral. Right. Y is called the limitless variable because limitless variable because you have the maximum or cap at upper level, and you can see that when you add these two, it gives you x, because this is basically x minus d if x is more than d, minus 0 if x is less than or equal d. And then the other one, x and d, is basically x if x is more than d, less than d, and then so that, and then let me write it in here, and then d if x is more than d. So you can see when you add x minus d plus d, it becomes x. 0 plus x becomes, so basically it's x it's more than d or x less than d. So that's why you will see this relationship. So when you have both policy deductible and policy limit, you need to first apply policy limit, then the deductible. So here you can see first apply policy limit, then deductible, U minus. So it's not like you will get U, because first you apply policy limit. So U, then you apply deductible, and so the if the loss exceed U, the insurance payment is actually going to be U minus D. So in middle you have x minus d. If it is less than, deductible payment would be 0. So actually this is an introduction. You are going to learn about all of this again in STAM class. So don't worry if you didn't go through in depth on this concept. We are going to come back to this concept in another class. Not in ACFF 4140, but in STM regular function. So here we have few SOA sample questions. We are going to do some and then see how to apply what we learn. So this one says an insurance policy reimburse a loss up to benefit limit of 10. The policy holder, so the limit is 10. So U equal 10. The policy holder loss Y follows distribution density function. Y is more than 1, 0 otherwise. Calculate extra value of benefit paid under the. So we want to calculate extra value of Y. We know the usual formula. But since you have policy limit U, we have to integrate from, anyway, it's going from 1 to infinity. So 1 to 10 y f by dy. Then from 10 to infinity, it's always y value is 10. 10 times f by dy. So remember, because policy limit imposed there, the loss reimbursed become fixed at policy limit 10 when it exceeds more than 10. So when you integrate this one, you can find, I'm not going to do the integration. It is simple task. For example, this y, fy is 2 over y is 3. 10 can be taken as constant, and then here you have to, and you can do the integration. The answer should be 1.9. Here is another question. It says an insurance company policy pays for random loss X subject to deductible of C. So now we have deductible of C, where C is between 0 and 1. The loss amount is modeled as country's random variable density function. Given a random loss X, the probability that the insurance payment is 1 is less than 0.5. So that the insurance payment is less than 0.5 is equal to 0.064. So So this one is saying the payment less than 0.5 is probability 0.64. But the loss, this is the insurance payment. So we have to connect it with the loss, random loss variable. So we have y, which is 0. If the loss is between x and c, deductible amount, and then x minus c, if it's more than c. So x can be more than c. Between c and c. Okay, so this shows us um, we need to calculate this. We have to use no variable. That would be, let me write this again. So that would be basically probability 0 less than x less than c plus 0.5. So if I use x minus c in place of y, I would get that one. X is more than 0 because loss cannot be negative. And then you bring c to the other side, you get c plus 0.5. So now I can integrate this 0 to c plus 0.5. The density function is fx dx, which is 2x cycles. Now, when you integrate this, it should be equal to, it would give you 0.5 plus c squared. However, the problem says that should be equal to 0.64. So that conclude 0.5 plus c equal 0.8 and c equal 0.3. Actually, you can take plus and minus, but I just took the plus sign because c cannot be negative. C is more than c is positive according to the problem. So you cannot have negative value. Okay, so here's another question. This one says a manufacturer annual loss follows distribution with density function is given. To cover its losses, the manufacturer purchases an insurance policy with an annual deductible of 2. Calculate the mean of manufacturer loss not paid by the insurance policy. So the question is not paid by the insurance policy. So after deductible is paid, we have to calculate what is the value not paid. You can see the loss start from 0.6. So basically, it would be 0.62 2 x fx dx. Then to cover these laws, the manufacturer purchase an insurance policy with an annual deductible of 2. Um, so it's basically a policy looking like limit of 2. So not paid. So what is the not paid amount? So it would be X. Let's write the random variable X. If X in between 0.6 and 2, or 2, if X is more than 2. Anything above 2, um, the payment made X minus 2. Okay, so here we have then again integrate from 2 to the infinity 2 times X plus 2 because of this. It's like you. This is like you. No? Okay, so this is more like 2 is more like policy limit. If you look at, if you look from the insurance holder side, this is calculated not paid. Okay, so when we integrate, so you can now integrate this function, this look like constant, and we can do the integration, and then answer should be close to 0.9342. I'm going to leave the last problem for you. If you have any question.